students, welcome back to my YouTube channel Learn Easy Maths. As I already in my previous videos, I informed and I promised you that I am going to get a new topic based on the 10th standard topic is going to be introduced. So that day has come today now. Today our topic of discussion is sequence and arithmetic progression. In order to understand the arithmetic progression well, first we need to understand what the sequence is. Okay, let's see this one. 1, 3, okay, 9, then it is 21, 1, 3, 9 and 21, and now it is 45. This I would say that it is a sequence. The next 4, 9, okay, 19 and 39. It is also a sequence. What is the main criteria to test or to check that sequence? When we look it, observe, when you look it very carefully, we have to find the relationship between the given numbers. See that 1, the next number is 3, the next it is 9, the next it is 21, the next it is 45. It looks bit of surprise and also it is very mysterious. We do not find any relation or correlation among the given numbers. But if you observe it carefully based on the logical reasoning, you will find that what exact the relation exists between these numbers. See that I am going to explain you. Please pay attention. 1 is the first number, 3. The next my number is 3 and I got this 9. What is the relation? Double of 3 is 6. Double of 3 is added to 3, it is a 9. Alright. Then double of 3 what? It is 6. Added to 3, it is a 9. Then double of 6 is 12. Double of 3 is 6. Added to it, the 3, we got 9. Then what is the double of 6? 12. Added to it, we got 21. Yes. Then what is the double of 12? It is 24. Added to it, we got 45. This rule follows. What is the rule? It is some rule that 3 double it and add, then 6 double it and add, then 12 double it and add. This is the way this relation exists in the given sequence. Okay. Similarly, when we just come and absorb these set of numbers, 4 and 9, what is the relationship between them? Plus 5. Okay. Then 5 is added to the first term, we got 9. Then double the 5, it will be 10, we got 19. Then double the 10, we got 20, it is equal to 39. This is also a form of a sequence. With these two examples, I can say very clearly and categorically that sequence is an arrangement of number, orderly arranged numbers following some rule in a definite pattern. Following some rule. What is the rule? Here some rule is there. Double 3, 6 add it. Double 6, 12 add it. Double 12, 24 add it. Similarly, and you go on. This is some rule is that every number is being doubled and added to its succeeding number. Every number is doubled and added to its succeeding number. Now, look at this third form of sequence. Okay. 3, 6, 9, 12 and 15. Okay. What is the relationship you find among these numbers? Here to the 3 added is 3, we obtain 6. To the 6 and it is 3 is added, we got the 9. For the 9 we added 3, we got 12. And for the 12 we added 3, we got 15. In the two previous examples of the sequence, you find some definite rule and some different order. Here also you find a rule, but it is somehow different from this one. Here for every succeeding number, the same term is being added. It is not so like this. Here the number is doubled, but here for every succeeding number, 3, succeeding to the 3 we got 6 by adding 3. Succeeding to the 6 we got 9 by adding 3. For the whole sequence we have added the same term, isn't it? And when you see this one, 6 minus 3, difference between the second term and this first term is 3. Difference between the third term and the second term is 3. And the fourth term and the third term is 3. And the fifth term and the fourth term is 3. When every two consecutive numbers are they made to just difference, we found the same term. So that is called a progression. It is in the form of a progression. And what type of a progression it is? The whole sequence, it is being arranged orderly by adding the same term. That 3 added 6, 3 added 9, 3 added 12, 3 added 15. So this 3, 6, 9, 12 and 15, it is orderly arranged number with the same term to the whole sequence. We call it is an arithmetic progression. It is an arithmetic progression. This is one example. Now come to another example. 7, 13, 19, 25, 31, 37. This is a sequence. Every orderly arranged number with some rule, we say it is a sequence. Now what is the rule and what is the order that we need to investigate here? 13 minus 7 is 6. The difference between these two numbers is 6. 19 minus 13 is 6. 25 minus 19 is 6. And 31 minus 25 is 6. And 37 minus 31 is 6. Throughout the sequence, we got the same difference. This type of sequence are called arithmetic progression. These two are what I discussed before you, my earlier two examples, this 1 and 2, they are just only a sequence, viewers. They are only a sequence, but they are not an arithmetic progression. What I discussed, the third problem, the fourth problem before you, this is a sequence as well arithmetic progression. From this we can deduce, or we can just make a conclusion, that a logical conclusion or logical deduction. From the deduction it is a deduce. Okay, we say that every arithmetic progression is a sequence. Every arithmetic progression is a sequence, but all sequences are not an arithmetic progression. See that this is all sequence, and an arithmetic progression. This is only a sequence, but it is not an arithmetic progression. So what is the definition of arithmetic progression? A progression in which the difference between the two consecutive number is same. When the difference between the two succeeding, that is the second number minus first, and third minus second, and fifth minus fourth, and 10 minus 9, 25 minus 24, every like this consecutive, that is the succeeding and to its preceding, we say it is an arithmetic progression. Let's know what is the general form of an arithmetic progression. What is the general form of an arithmetic progression? Let's we say that I would like to just make an appeal to all my very esteemed viewers and all my very good students and my friends, colleagues and teachers and everybody whosoever watching the video. Please do subscribe and share it and just circulate it in a large way so that it should reach to each and every person who is in need of, in quest of knowledge. Okay. Now, A is the first term, A plus D, A plus 2D, A plus 3D, etc. A plus n minus 1 into D. This is the general form of an arithmetic progression. General form of an AP. AP stands for arithmetic progression. Okay. This is the general form. Let's we take an general example of this one. Alright. We take a general example of this one. Right. First term is 2. A is equal to 2. The second term is A plus D. What is that D now? The D is a difference between the second minus first term, the two consecutive term. Okay. So find the difference. What is 6 minus 2? It is 4. 10 minus 6, it is 4. 14 minus 10, it is 4. Alright. Now, okay children. Now see that one. First term is 2. Second term is 6, third is 10 and the fourth is 14. We will write this in the form of A plus D, A plus 2D in this one. Okay, let's make a margin for this one. The first term is 2. I hope you understand this one. And the difference for each consecutive term is what? 4. And you write, listen here and look here children. Just you write this one, A is 2, alright, A is equal to 2, that is same. A plus D, what is A? 2 and D is 4. A is equal to 2, it's same, it is a 2. And A plus D, A is 2 and D is 4. A plus 2 plus 2, what is D? Again it is 4. Then A plus 3D, 2 plus, then what it is? 3 into 4. Right. So do you find this one? A is equal to 2. A plus D, 2 plus 4. A plus 2D, 2 plus 2 into 4. A plus 3D, 2 plus 3 into 4. And so on. This is the last nth term. This is called the last nth term. Okay. This is the general form that how we write this one. Alright. Similarly, you take another example of multiples of 7. Okay. How do you write? So what is the first term? It's a 7. What is the difference? How to find the difference? Simple. Second term minus first term. Difference between every two consecutive terms, we find the difference. 14 minus 7 is 7. 21 minus 14 is 7. 28 minus 21 is 7. Now, you write in this A plus D form now. A is 7. A is equal to what? It is a 7. A plus D, that is 7 plus 7. A plus D, that is 7 plus 7. A plus 2D, 7 plus 2 into 7. A plus 3D, that 28 can be expressed as 7 plus 3 into 7. A plus 4D, that is 7 plus 4 into 7. You get the same thing. A is equal to 7. A plus D, 7 plus C, 7 plus 7 is 14. And A plus 2D, 7 plus 2 into 7, 14 plus 7 is 21. a plus 3d, 7 plus 3 into 7, 21 plus 7 is 28, and a plus 4d, 7 plus 4 into 7, that is 28 plus 7 is 35. This is the way that we are going to write the general form. So you understood, I hope you understand well that what is the general form, how we are going to write this one. Okay. Now I just prove that one, an formula. Okay, in a simple term, it's not going to be somehow a rocketry science or something, it is a quantum mechanics or the quantum physics. Let's we understand whatever the topic in our very simple and very lucid manner. Okay, now look here, viewers, see that one. I'm going to take one example. 4, 8, 12, 16, 20, 24, 28, 32. Right? Okay. This is an AP whose first term is 4. Common difference is 4. 8 minus 4, 12 minus 8, 16 minus 12, 20 minus 16, and so on. So, we will make a list of all the things. First term 4, difference is 4. Okay, the nth term, the last ending term is 32, and the n means total terms, total number of terms of an AP. How many terms are there? 1, 2, 3, 4, 5, 6, 7, 8. Okay, n is equal to 8. Look here. So I will say that what exactly an represents. An is equal to a plus n minus 1 into d. How are we going to explain? An is the last term. Okay. A is the first term. Okay. N is the number of terms of an AP, and d is a difference. Let's prove that LHS is equal to RHS. What it is now? What is an? It is the last term 32. Okay. Then what is the first term? It is a 4. Then what is the total number of terms of given in AP? It is a 8 minus 1. And what is the difference? It is just 4. Okay. 32 is equal to 4 plus, what is 8 minus 1? 7 into 4. That is 32 is equal to 4 plus 7 4s are 4 7s are 28. Therefore 32 is equal to 4 plus 28 is 32. This is only our nth term formula. An is equal to a plus n minus 1 into d. Do you understand this one? This is simple things. This is only the proof. It is what is an, what is a plus n minus 1 into d. Here only by taking this AP I have explained you. So a is 4, difference is 4, last term n is 32, n is equal to 8. Then you prove this formula, an is always equal to a plus n minus 1 into d. An 32 I put because it is the last term, a is the first term, n is total number of terms, 8 minus 1, and d is the difference. Now when you just calculate it, manipulate, 32 is equal to 4 plus 8 minus 1 is 7, 7 into 4, 28. This is the simple way we should understand what is the an formula. Okay. Now by taking the same example, I am going to just miss out some of the things and I will make you to find what exactly it is. See, I have to find what is an n. I have to find what is an n. I know that the first term, I know the difference, and I know the last term, but I don't know how many terms are there. How many terms are there in the given AP? Let's see that what happens. See, an is equal to a plus n minus 1 into d. Alright. So, what are the known things given? You substitute. An is given, substitute 32. A is given, substitute 4. N is not given, write as it is. What is not given? We have to just put the same thing without any altering. What is the difference? It is a 4. We have to find what is the n, means how many terms are there in the given AP. Example I am showing. Calculate 32 is equal to 4 plus inside the bracket n minus 1, outside it is a 4, multiply 4 n's are 4 and 4 1's are 4. LHS is 32. RHS is 4 plus 4n minus 4 plus 4 minus 4 with an opposite sign, they get cancelled. 32 is equal to 4n or 4n is equal to 32. Therefore, n is equal to 32 by 4. 4 ones are 4 eights are. That what it shows, there are 8 terms are there in a given AP. When we count it 1, 2, 3, 4, 5, 6, 7, 8, there's 8 term. But this way, if an given, a given, d given, we can find out an easily. Rather, I would miss some of the things. Let, what is that one? I am going to miss here the d. Let's what happens now. We have to find what is a d. Alright. Then write that one. An is equal to a plus n minus 1 into d. What is an? 32. What is a? 4 plus what is n? 8 minus 1. And what is d? We don't know. We have to find it. Alright, we have to find. 32 is equal to 4 plus 8 minus 1 is how much? It is 7d. It is 7d. Now, LHS 32, RHS 4 plus 7d. As for the equation rule is there, whatever the variable that should be retained to one side and whatever the constants are there that should be collected at one side. Here 32 is a constant left side, right side is 4 is a constant. 32 minus 4 is equal to 7d because d is a variable, because the unknown term in a calculation and the unknown term in arithmetic, which is called as an algebraic terms. So 32 minus 4 is equal to 7d. 28 is equal to 7d. 7d is equal to 28. Therefore, d is equal to 28 divided by 7. 7 1 is 7 4. So we found the difference, common difference d is 4. Okay. What did we find? First, by missing out the n, we found the n. By missing out the d, we found the d. Now let's miss out what this is 4. That's the first term is. Okay. We can find how the first term is. Let it be. We don't know what is the first term of a sequence. Right. What happens? See that one. An is equal to, okay. An is equal to a plus n minus 1 into d. An is 32. A we don't know. N we know 8. And what is this? This is 4. Alright. First, we found n by missing out that we how to find the n. Then next, we found the difference of the AP 4. Now, thirdly, we are finding how to find the first term. 32 is equal to a plus 8 minus 1 is how much? 7 into 4. 32 is equal to a plus 28, or a plus 28 is equal to 32. Therefore, a is equal to 32 minus 28. A is equal to 4. How we found this? See, if one term is missing, we can find that missing term with the help of the given terms. This is the way that we have just started and discussed about what is an, what is a, what is d, and what is n. Alright. Now the next thing is, I am going to just take some example for that one. Okay. What is that example? I would say that one. 4, this is what, how much it is? Then 12, alright, 20, etc. 86. In this given progression, you are required to find and test whether this 86 is a term of this given progression. As you know that 4 is a term of a AP, 12 is a term of AP, 20 is a term of AP. Similarly, 86 is given. Whether 86 is a part of the progression or not, 86 is a part of that sequence or not, that you have to find. How to find now? The first term, just make a list here. Checklist A is equal to 4. Alright. And the difference between the two terms, consecutive terms, second minus first, 12 minus 4, the D is what? 8. 20 minus 12 is 8. Let's assume that, because still we have to check it whether what is the CT. Let us test it that 86 is a term of this given arithmetic progression or not. So write an is equal to a plus n minus 1 into d. Okay. What is an? We assume it that 86 is the last term. Because why I am saying that is an assuming? Because that is the part of the test. No, we are not sure about that 86 is a number of, or it is a term of a given arithmetic progression or not. That's the reason I am saying that assume it. Then first term is 4 plus, we don't know how many terms are there. So that's why write n minus 1 into 8. Alright. 86 is equal to 4 plus, outside the bracket it's 8, inside the bracket it is n minus 1, multiply 8 n's are 8n, 8 1's are 8. 86 is equal to 4 minus 8 plus 4 minus 8 is a minus 4 plus 8n. Alright, minus 4 plus 8n. Then now, as per the equation, we have to collect the constant one terms and retain the variable on the another side. So therefore 86, this 4 is transposed to the left hand side, it is plus 4 is equal to 8n. Minus 4 comes to the left side, it becomes plus 4. Now 90 is equal to 8n. Therefore 8n is equal to 90. Then what about n? N is equal to 90 divided by 8. When n is equal to 90 divided by 8 is not divisible, because 8 doesn't divide 90 completely. If doesn't divide 90 completely, therefore the term, the number which is given along with the sequence arithmetic progression is not a term, or it is not part of the progression. Therefore we say that 86 is not a term, it is not a number of a progression. By this way we can test it properly. Understand? So friends, this is all about our today's the first part of in the series of the arithmetic progression. That this is the video. I hope you understood, because what is my efforts and endeavor that not to solve the full exercise. Because what is the just the significance and the meaning or the purpose in solving the exercise? Because for solving the exercise you have your own school teachers, maths teacher, as well as the tuition teachers, as well as you have the many study material and helping sources. But my purpose is just to only make you understand the concept of what the topic is. With this, I am going to disappear from your screen. Now, I hope that you will subscribe it, you will share it, and you will view it again and again and make spread among your friends. Particularly, this is an appeal to my all young students of the 10th standard students, and use this opportunity and go through it and learn well. With this, I would take a leave from you. May God bless you. Thank you. Bye-bye.